Jai Hind to all of you. I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering at Akgec Engineering College, Ghaziabad. So today I am going to discuss about cellular infrastructure, and this is part 4. And in earlier series, part 1, 2 and 3, I had discussed about the basics of cellular infrastructure. That included how we are dividing the area into cells, what should be the shape of the cell, what is the distance between the different cell centers, and then we discussed about the concept of frequency reuse. In another lectures, I discussed about the type of antennas that we are using, omnidirectional antenna, directional antenna, and then I also discussed about handoff, in which I discussed about the soft handoff, hard handoff, and then network assisted handoff, mobile assisted handoff, all these things. So I will continue with that lecture. So firstly, we will discuss about the few terms associated with handoff procedure. First is handoff probability. Handoff probability it is the probability that a handoff is executed before call termination. So that means we are on call and we are moving from one cell to another cell, and this is the probability that handoff has occurred before the termination of the call. So this is one of the terms. Rate of handover. That means the number of handovers per unit time. How much number of handoffs are done in a, is called rate of handover. Interruption duration. It is the duration of time during a handover procedure in which a mobile is not connected to any base station. Two cells are there. One user is within the range of particular base station, and this call is being transferred to the another base station, and there is a in between there will be a time in which there will be no connection. So that is called the interruption duration. Handoff delay. It is the distance between the point at which the handoff should occur and the point at which it does occur. This we will call the delay. Probability of unsuccessful handoffs. It is the probability that a handoff is executed while the reception conditions are inadequate. So probability of unsuccessful handoffs. Handoff blocking probability. It is a probability that a handover can't be completed successfully. So that is the blocking. So these are the important terms that are used. Handoff probability, the probability of handoff. Rate of handover, how much number of handoffs are taking place. Interruption duration. So whenever call is moving from one base station to another, in between if there is some interruption is there. Handoff delay, probability of unsuccessful handoffs, and handoff blocking probability. Now the next topic is, so this is another condition. That there is a one condition during handoff that is called the ping pong effect. Ping pong effect. The name of phenomena implies that mobile station moves back and forth between the overlap of two adjacent cells. So whenever a handover has to occur, if a particular user, this is a particular user, is on a mobile station, we are saying, and this is one cell, this is another cell, and between there is a boundary. If the user keeps on moving at this boundary, then it becomes difficult for the MSC to take decision whether the user is coming towards cell 1 or it is going towards cell 2. So it becomes difficult for the MSC to take decision, and such type of effect is called ping pong effect. The solution is to allow MSC continues maintain a radio link with the current base station until the signal strength from the base station exceeds that of base station by some pre-specified threshold value. So the important solution is that the connection to the first base station should be there unless and until there is a proper decision has been taken to move to the other base station. Now the next thing that we discuss about cellular infrastructure is channel assignment. As in cellular infrastructure, every base station will be provided with a particular range of frequencies. So the channels should be provided so the user can communicate through those channels. Now there must be some strategy to give this channels to the user, to the service providers. So the channel assignment. In heavy traffic conditions, all active subscribers in a cell may use up all the channels, and there may be demand for extra channels. As in the previous lecture also, I had taken one example that if total number of cell frequencies are 100 and 10 cells have been given, each cell has been given the frequency of 10 frequencies, then at some particular time, if all of the 10 frequencies are being used, that means 10 users are on call, then if another person comes in that particular cell and he demands for particular channel, then how to take care of that particular problem? So demand for extra channel. The aim of channel assignment is to efficiently use the available radio spectrum and to provide the best possible service so that a subscriber doesn't lose any call due to unavailability of channels. So the reason for this, if somebody comes or wants for any other frequency, want to use any frequency, then he shouldn't be provided with particular frequency, otherwise he will not be, his call will not be taken care of due to unavailability of channels. So there are two ways in which channel assignment is done. One is fixed channel assignment, another is borrowing channel assignment strategy, another is dynamic, fixed, borrowing, and the third one is dynamic channel assignment. In fixed channel assignment, as I have told you, if 100 frequencies are there, each one will be given, each cell will be given with 10 frequencies. So that is called fixed channel assignment. In this fixed channel assignment method, each cell is allocated a predetermined set of voice channel. Only the unused channel in a particular cell can serve any call attend within that cell. So if 8 of the 10 frequencies are used, then only 2 frequencies will be available in a particular cell if somebody demands it. Then if all the channels are occupied, then the call will be blocked and the subscribers will not get any service. So if any 11th person comes, he will not be able to access the services. In borrowing strategy, very important thing, very beautiful thing that is used in cellular infrastructure, that is called borrowing strategy. So that means if any cell is a shortage of frequencies, if 10 frequencies he has used all of the frequencies and he wants 11th frequency, then he can borrow that frequency from his neighboring cells. So such type of channel assignment strategy is called borrowing strategy. A cell is allowed to borrow a channel from a neighboring cell if all of its own channels are occupied. The MSC supervises the borrowing. The BSCs can't take the decision by themselves. It will be monitored by MSC and ensures that the borrowing of the channel doesn't disrupt or interfere with any of the call in progress in the donor cell. It shouldn't be there that if I am already short of frequencies and I am don't bring my frequency to the neighboring cell, this shouldn't be there. That is taken care by the MSC. Now the third thing, that is dynamic channel. Now in the case of dynamic channel, all of the frequencies will be available with the MSC. Now they will not be provided to the different cells at a fixed level. They will be provided to them dynamically on the basis of requirement. So if I want any frequency, then within a particular cell, then that will be taken care by the MSC. In the dynamic channel assignment method, voice channels are not allocated permanently in any of the cell. When a call request is made, the serving base station requests a channel from the MSC. So he will request the channel from the MSC, which then allocates the channel to the requested cell. So means a whole of the frequencies will be with the channels will be with the MSC, and he will assign the channels to the different users on the basis of demand. Advantages of dynamic channel assignment: the likelihood of call blocking reduces, blocking will be reduces, co-channel interference reduces, and channel utilization increases. Now how the call blocking reduces? As if any particular cell is depleted of frequencies, 10 frequencies have been used, and for the 11th user, he will block the call. He will say that I am not having any frequency, so I can't make the call. But this is not the case with this dynamic channel assignment, because all the frequencies are with MSC, so anybody can demand the frequency from the MSC. Another thing is co-channel interference. If we are assigning the frequencies on a fixed level, then we will be assigning bunch of frequencies to different users. On, for example, if I am having 100 frequencies, I will be giving 1 to 10 frequencies to the first user, then the next 10 to the next user cell, and the next 10 to the third cell. So here the chances of co-channel interference will be more because the channels will be adjacent to each other. But in the case of dynamic, MSC is providing the frequencies to different users. So the probability of two co-channel cells having the same range of frequencies or adjacent frequencies will be less. So the co-channel interference will be less, and channel utilization increases. Disadvantage is that MSC must be fast and capable of collecting real-time data on channel occupancy, traffic distribution, and radio signal strength indications of all channels. Now the whole of the burden is on the MSC because he has to continuously monitor everyone. Whenever they want any frequency, they have to take care of all the things. They have to provide the frequencies. They have to take care that two nearest channels cells may not have the same frequency. So all these things are taken care of MSC. So it increases the burden on the MSC. Now, lastly, also we will discuss about co-channel interference. So in cells, there are two main types of interference. This is also very important concept of cellular infrastructure, that is channel interference. So there are two types of interference. One is, this one we are discussing about is co-channel interference. Now what we mean by co-channel? Cellular systems uses the concept of frequency reuse. That means two different cells are using the same frequency at the same time, but they are at a certain distance from each other that is prescribed as per the regulations. Now, even if they are separated apart, there will be some disturbance or interference due to these co-channel cells. So, this is called co-channel interference, as visible from this diagram. As you can see here, if I am talking about this particular cell, he is using a set of frequencies A. Now, there are 6 adjacent cells who are using the same set of frequencies. This cell is using the same set of frequencies due to frequency reuse concept. This is also, they are at a particular distance from each other that they can use the same frequencies. This same set of frequencies, this. Now they are at a particular distance from each other. Even then, there may be some interference due to these particular cells, and this type of interference is called co-channel interference, as all these cells are using the same set of frequencies. This first circle will come under tier 1, then this second circle will be tier 2, where we are having these cells. Then there is tier 3. Obviously, as we move away from this cell, the interference will be less, but somehow there will be some effect of these interference from these particular cells. Then another mobile sources of interference can be another mobile in the same cell, a call in progress in a neighboring cell that can cause interference, other base station operating in the same frequency band, any non-cellular system which advently leaks energy into cellular system. So these are the causes of interference. Interference causes crosstalk. Due to interference, two persons are speaking. They are speaking at the same frequency. They are close to each other. Then ultimately this will result in crosstalk, where the subscriber hear interference at the background due to undesired transmission. On control channels, the interference leads to missed and blocked calls. Two types of channels are being used. One is for communication of data, that is the voice or anything can be there. But another is the control signals. In control channel, that is continuously monitoring the power of your signal, whether you are moving from one place to another, and all these things. So in case there is some error in the control signals, it will result in blockage of calls or missing of calls can be there. So these will be the effect in the case of control channel. So interference, that can be co-channel interference or adjacent channel interference. So interference, co-channel interference, frequency reuse implies that a given coverage area, there are several cells that use the same frequencies. These are called co-channel cells. All I have already discussed. These are clusters, and they are these cluster, this A and this A, all are using the same set of frequencies. Unlike thermal noise, which can be overcome by increasing the SNR, co-channel interference can't be combated by simply increasing the carrier power of the transmitter. If I am saying signal to noise ratio, that is clear to all. Signal to noise. How much signal is there and how much amount of noise is there. If I want to decrease the effect of noise, what I will do? I will increase the level of signal, the power of the signal that we will increase. But in this particular case, if I increase the power of my signal, if at this particular base station I am increasing the power of the signal so as to decrease the interference, what will affect? The power will increase and it will start radiating to a more distance. So the power interference at the adjacent channels, the clusters will increase. So this is not the solution in the case of cellular infrastructure, that if we can't increase the power of the signal. So we will have to use some other strategies, because an increase in carrier transmit power increases the interference to neighboring cells. To reduce co-channel interference, co-channels must be physically separated by a minimum distance between there should be a minimum distance between the two cluster centers to provide sufficient isolation. So it will depend upon the radius of the cell, distance between the nearest co-channel cells. So therefore, increasing the ratio d by r, that is the distance between the co-channel cells and the radius between coverage system, so the distance between both the co-channel cells will increase and ultimately the interference will be reduced. So this is one of the way in which by taking care of d by r ratio, we can decrease the interference, co-channel interference. So today we discussed about the another concepts of cellular infrastructure, that included the important terms in handover. Then we discussed about the ping pong effect. We discussed about the channel assignment, fixed assignment, borrowing strategy, dynamic assignment, and then we discussed about the interference that occurs in co-channel cells or adjacent channel interference. Then we discussed that how to take care of this interference by having a particular d by r ratio. The rest we will discuss in the next class. Thank you. Thank you for watching.